Hello everyone, it's Andrew here, aka May Day, and I'll just be going through the Armattan Morphite 180 build, just going through all the components that go in to make it fly. So we'll start with kind of just the general components, and which you usually receive in most kits. So obviously you start with the frame here. This is the base plate, this is the top plate here. We have all the hardware that goes alongside that. We also have the Armattan Mullet Acro with the supporting components. We have the power distribution board that you can see here, as well as the 5-volt regulator. As the ESCs that I'll describe later do not have a 5-volt BEC on them. You also come with a bunch of supporting hardware such as zip ties, XC60 connector wires, some JST leads, some motor screws. The motors are themselves. This particular build I'll be using the Lemon satellite receiver, and then we've got the Armattan 20 amp ESCs, which are opto ESCs, meaning they have no BEC on them, so they don't put out 5 volts. So I'll just quickly go over each component individually and describe them a little bit. So we'll start with the ESCs since I have them in hand. So these ESCs, in particular in this build, are running BL Heli 13.2. So obviously, depending on when you watch this video, you might have a newer version of Bela Heli, or you might even have Simon K. These ESCs are a pretty popular ESC. They're pretty well known at this point in time, and they perform great. And the great thing about them is they're super small, so they fit very nicely on these arms and make for a nice clean build. So in terms of building with them, you have your wires that run to your power distribution board, and this wire that goes to the flight controller. Now, some people say that you can run these without a ground wire to the flight controller, and while I have been testing this quite a bit and I haven't had any issues, there is still a potential for some weird things to happen if you're not running ground. Basically, if there's enough noise on this ground wire, when your motors are pulling a lot of current, it means that the ESC doesn't actually see the signal properly when that happens. But because this is a lower power system compared to a lot of 250s that are running 4S and 604.5 on about 2000 kV motors, this one doesn't really have that kind of noise, and that's why I don't think you don't really see any issues with running just the signal wire. So obviously I still recommend building with the signal wire and ground going to the flight controller, but if you are so inclined you want to make a nice clean build, you can run just the signal wire. So this is just a Lemon satellite, so this interfaces with any DSMX radio, such as a Spectrum radio or any kind of module that runs in, say, like a Tyrannus or something like that. So the nice thing about this is it's just a simple 3-wire connection to the flight controller. You don't need any of that crazy PWM 6 or 7 wires, depending on how many channels you run. It's just a single wire with power and ground that runs to your flight controller. And then you can get all the stuff that Spectrum or any DSMX protocol uses. You can also use any a true Spectrum satellite, but these ones are much cheaper and do the job equally as well. So then we have the motors. So these Armattan 1306 motors, and so these ones have clockwise and counterclockwise nuts on them. The nice thing about this is that they auto-tighten, so that means you never really have to tighten these with a wrench, and I rarely do. It's all with my fingers. So you take out the old prop, say you broke it, or you just want to put different color prop on or something like that, you just unscrew them, put the prop on, and then tighten them down with your fingers. And once they're nice and snug, then you can go fly. You can go, and they auto-tighten once you spin up. And I've never had a prop nut come off with these, so it's really nice for that. So to tell the difference between the two, with these ones you can see the clockwise and counterclockwise symbols there on the motors, and then on the bells themselves. Let's try to get this really nice and close. So this one's nice and smooth for the standard motor, so this is like any motor you have, so to take off the nut it's lefty-loosey, like this, and to tighten it's righty-tighty. So that's the standard motor, like any motor that you're used to. And then this is the reverse thread, and it's got the 2 little rings cut into the cone on the top, so this makes it obvious when you're looking from the top you can see what those are. And to actually loosen that one is you have to turn to the right, which is a bit counterintuitive, but obviously the reverse thread is going to be counterintuitive. So righty-loosey, FD to tidy. So these motors run great with these ESCs, well tested, and they also come with all the bolts to actually attach them to the frame. There's some other stuff here. So it's power distribution board. Obviously you run all your ESCs and your XD60 connector, and then the power wire to the mullet board. And then there's also the 5-volt blue regulator. This is a 1 amp version that I'm using today, and most kits usually come with a 1 amp version, though this can change. This basically will get soldered directly onto this right here. So you've got your 3 pins, 5-volt grounded in, and that's to correspond with these in here. So V in, ground in, V out. And so how you can hook these up is either use the headers that come with the Palula regulator to actually solder this a bit higher up here. But what I like to do is actually just surface mount it. So I will solder this directly onto there, so keep it nice and low profile. And basically what you can do then is you got a bunch of 5-volt spots, and you can pull 5 volts out. If you want to put a header out here, you can connect pins to it or solder directly to it. But I'll show you how I connect that to the flight controller later on. Next, I think we'll talk about the XT60. So this comes with an XT60. This one I'm building. I use black power wires. Obviously, if you want to use a red power wire to keep it a bit more obvious, but basically once it's hooked up, it's almost impossible to connect these backwards. So as long as you hook them up correctly, you don't have to worry about it, and it looks a lot nicer with all black, in my opinion. Flight controller. So this is the Mullet Acro. Great little board. And it runs base flight or clean flight. For most of the builds that I do, I'm using clean flight now, just because it's so much more robust, got a lot more community support, and is overall just a great firmware. So what I usually run on these is clean flight 1.8.1, which is currently the latest stable version. Obviously that'll depend on what point you're watching this video as to what the latest stable version is. But I'll go over all the settings for this board later on once the quad is actually built. As well as I'll go over all the connections for something like this satellite receiver, because that's a bit different to connect compared to other things. And then last not least is the 180 frame itself. So this is the 3mm carbon fiber, pretty darn strong. Obviously, if it isn't strong enough and it breaks, it's got a lifetime warranty on it. So you just got to message Chris at Armattan Quads, and you can get a free replacement no matter what. As long as it is broken, like as in if you scuff it or something like that, doesn't really count. It has to be so it can't fly anymore. Then he'll replace it for you. So this is a lifetime warranty as well, so as long as the frame exists, and it is transferable between anyone who buys it. So if you buy the frame from someone else, you still have the warranty as well, which is pretty awesome, so you never have to worry about replacing this frame and never having to pay to replace the frame ever again. So I think that's about all, so I'll just start with the assembly. So we'll start with kind of some of the hardware to go on here. So when I build it, I usually like to use a little bit of heat shrink over the arms. This means later on when we attach the ESCs, we won't use zip ties to do that. Zip ties work equally as well. I just like the cleaner look of the heat shrink, but it's completely up to you. I can't remember the exact diameter of this heat shrink. I think it's 12mm. Something like that. No, it's probably a bit bigger than 12. It's probably about 20mm to fit over the arms, basically. So once you've got that slid over there, you're going to take the M3 by 12mm. That's what's currently in the kit that I'm putting together here, but this could change slightly. Metal bolts. So the idea is you want the strong metal bolts for your landing gear. So you'll put them in like so. Grab some of your M3 by 25mm standoffs and just screw those down. So I guess, yeah, I didn't really go over the tools that are not required but recommended for it. So this is a H1.5. This is for all your motor bolts or M2 hardware. So that will go into the motors. I recommend making sure you have a good H1.5 hex driver, because you can seem to round them out a bit with older drivers. So these ones for me are pretty new, and this is an old RCX one that I have, H1.5. I find that this tip has started to round out a bit, so when I actually try to put these bolts in, it actually will round the hex out. So just make sure you got some good quality drivers, or at least newer drivers, for these smaller bolts, so you don't round them out. So that's the 1.5, so that's all for all M2 hardware. Then this is the H2.0, and this is for all the M3 hardware, as you can see there. Again, make sure you got a good driver for that. I've got some wire snippers, so I use these for cutting wires and for taking off the silicone sheath. An X-Acto knife of some sort is usually a good idea for cutting things. Scissors for opening packaging. I've already opened most of the packaging on this, so you didn't see any of that. So a pair of pliers and or a pair of tweezers is also a pretty good idea. I seem to have misplaced my tweezers. There they are. So with this smaller stuff, it's usually a really good idea to have a pair of tweezers, just because the wires are pretty darn small, and trying to hold it by hand or with even with a pair of needle nose pliers is sometimes too big. So a nice little pair of tweezers, and you can really hold wires exactly where you want them, and get into very tight locations with it. So I definitely recommend grabbing a pair of tweezers. I think this is just something I got from Hobby King, anti-magnetic ones, so they don't stick to bolts. I think that's about all the required hardware that I can think of off the top of my head. Obviously a good soldering iron. So I've got a temper controlled one with a decently small tip. You don't need a large tip for any of the work you're doing here, because all the gauge on all the wires is pretty small gauge. The JST is probably, oh no, actually the LiPo wires are probably the biggest one, and they're 16 gauge. Yeah, so let's get started. So we've already started with the frame assembly here. So now we put the landing legs on. So that's front, A at the back. We can put the pieces in the middle. So we'll start with the power distribution board and flight controller stack. So what that is usually you use the M3 by 12 millimeter nylon bolts. These will go into the holes around the outside. So this is the pattern for a standard 36 millimeter flight controller. So that's basically the majority of flight controllers in this size will run there. So you've got 1, 2, 3, 4. To hold these on, we use the M3 nylon nuts. And sorry, I just had to do that a shot. It was super awkward trying to get around this camera and tighten bolts like that. So yeah, you get those tightened down. Those are all the M3 nuts tightened down. And then we can take the power distribution board and we can stick it on here. I like to stick it with these parts, the 5-volt header on the right side. This can depend on the way you plan to build it. The reason for that is then the ESCs can connect to the front to here, the back ESCs connect to the front back to here. I can put the LiPo connection out the side, and then I've got 2 sets of spare pads for other connections. So once those are on there, we'll take the M3 by 12 millimeter standoff and screw those guys down. So once you got those 4 down on there, then you take some of the M3 metal bolts, the short guys, and stick them into these holes here. And this is for the top plate, but I like to stick these in so I have an idea of where my ESC wires will run. So you just tighten those down by finger tighten them. So that's basically how the main plate is attached. It gets stuck on there. Alright, so that's the easy part. All the hardware assembly. Next we're going to stick the motors on here. So to keep in mind which ones go where, your reverse ones, the ones with the little rings, are front left, so that's the front of the quad. And then your standard ones are front right, standard one, back left, reverse one, back right. So basically you have reverse, reverse on the front left and back right, and you have standard and standard on the back left and front right, as you can see here. So this means that when the motor is spinning up, the nuts are actually tightening down on the props. So to do these guys, we will use some blue Loctite on the motor bolts. This is not required, but it is recommended to stick some of this on there. This means that they won't vibrate out over time, and the motor won't randomly fall off. So I usually just get an old plastic bag or something that these came in, ooze a bit of this stuff onto there. You don't need much, just a little bit. Basically, you'll dip the screw tip into this every time you put a motor bolt in. So this is going to be a bit awkward angles here, so I might have to take it off shot for a bit, but I'll just show you the first one. So this is a reverse. No, we want a standard. We're going to start with the front right. It's a standard. So you're going to take the bolt, set it on your screwdriver, and just touch it into the tip and roll it around, so you just have like a little blob on the end. So you stick it through any of the bolt holes here. I'll just start with this one, why not? Go through. Oh, I'm getting caught on things already. You probably can't see this. So yeah, you start with there. See the bolt through there, it's got a bit of a thread lock on it. You just lightly turn it in. So you don't want to tighten this one all the way yet, just a couple turns so it holds it. Because then you have to make sure that you line up the other holes before you tighten it down. So we'll get the second one primed. Lock it on. Tap it. Little blob. Build a cross hole. And screw that in. So basically, once you got the first two in, you can tighten these ones down all the way. You don't want to over tighten them because of the thread lock. You don't need to over tighten them at all. Just gotta tighten them down a little snug, and boom, there you go. So you can use only, if you're using thread lock, you can use only 2 screws, as to make sure you got enough thread lock on there like you saw that I just used, and then you can only have to use 2 bolts. If you're not using the thread lock, then I advise you stick all 4 in, and then you tighten them down quite well. But this helps reduce the weight a little bit by only using 2 bolts. Obviously, you're not saving a huge amount, but every little gram counts on these little guys. So the next thing I do then is I just trim these motor wires to get them out of the way, because our ESCs are going to be sitting right here, like so. We can trim these wires down quite a bit. So I usually go at the edge of the motor bolt, or sorry, the standoff bolt there for the landing gear, and I kind of just add, I don't know, a couple millimeters, 4 or 5 millimeters to that, and trim it. Like so. So what you do, once you got that trimmed off, you're going to have to expose about 3 millimeters on the end of these for soldering to the ESC. So I usually just grab them like so. Grab it, pull it. There you go. So you can do this before you stick the motor on the arms, but I just find it's easier to calculate the length that you need out the end. But once you do a couple of them like I have, I usually do them before sticking them on here. So there you go, all ready to go. So once you have them open like this, then you tin them. We'll go over that later though, once I put all the motors on. Okay, so now that that is all done, we've got all 4 motors attached, all with 2 bolts in the bottom with Loctite on both of them. We have all the wires trimmed, and we have the actual wire itself exposed, ready to be tinned with a soldering iron. So the next step that I'll do now is just putting this XC60 connector together so that we can install it on the power distribution board. So I have the 2 sets of wires for it. I just trim off enough for that to go into the connector. Get this guy out of the way for now. And then we're going to turn on the soldering iron. That's pretty useful. Grab the helping hands. My crappy pair of helping hands, but they do the job. We're going to quickly first tin these wires. So if you're new to soldering, depending on where you come from, how you pronounce it. I say soldering for the hell of it, even though I'm Canadian. The biggest thing you can do is always tin all your wires before any connections or any surface that you need to do any type of soldering connection to. Always tin it first. So these are bare wires, they don't have anything on them. They will not take weld to another surface with solder on it unless you prime them first. So I just cleaned my tip there on the soldering iron. The soldering iron is now at 350 degrees Celsius, whatever that is in Fahrenheit. It's 650-ish. So basically I'm going to apply a bit of heat to it and apply the solder from each side until it starts leaching all the way across the wire. Once you see it come out on the far side, hold there for a sec, let it bubble down, burn off the flux. So the stuff I'm using here is lead full, none of that lead free stuff. And so it means it goes really nice into the wires. It's got built-in flux. It's just some next deck stuff. Don't need anything too thick for this kind of wire stuff. So again, it's just a small tip. And this is what, 0.8 millimeter solder, 60-40. Okay, so those are both primed. So I'll just stick them over there. Keep in mind that they will be quite warm right after you tin them like that, so don't touch them right away. I've done that a couple times where I wasn't thinking. And you grab them as you're pulling them off of there, and it hurts a little bit. So next step is we'll put some solder into the connector, like so. Pull these guys out, and we'll just get a bit more solder onto the tip of the iron, and hold it down until it melts. Really good. So you want the entire joint to be nice and flowed. Let go until it cools. Try not to move it too much as it cools. With these bigger joints, they take a couple seconds to actually solidify. And if you move them around while they're solidifying, it can actually weaken the joint. So we've done one. Again, keep in mind that everything's going to be very warm, so this wire right now is quite warm on my fingers, but not so much I have to pull away. I'll do the second one. Also keep in mind the fumes for this stuff is not the best to breathe in. If you're looking out for your health, do not inhale. We have got each wire connected there, boom and boom. They both look like good connections. Because the gauge of this wire is a lot smaller than the actual connector itself, they do look like they're kind of small, but that's a perfect connection right there. So next step is sticking some heat shrink over these. So usually I like to let them cool a tiny bit, because if you start sliding this heat shrink over, all this metal is still pretty hot from your soldering, and the heat shrink will shrink before you get it all the way down, and then you'll have to start again. So slide it in, and grab the other one, slide all the way down into there's a little gap in the housing, so you want to slide it all the way into the housing, so there's no chance that anything is going to contact on the outside. And for these guys, I usually just I do have a heat gun, but I usually just touch it to to this thing quickly. Let's get a quick stroke. There's our XT60 connector done. So I'll stick this onto the quad itself. So again, front, I like to stick it down under the left side like this. So this is the complicated part where I've got both black wires when I do these builds. So basically you just gotta check this side's positive, this one's positive, and then check for the positive tab there. So I'll do this one first. So we'll tin this guy on here. Let's do both of them while I'm at it. Because these are the LiPo connections, you want to use a good amount of solder on these ones. Get a good bubble going. So you usually do a quick touch to fill the hole, like so. You go back and just apply another little touch on top of that. And we'll just prime this guy as well. So again, hold to the side for a second, get some heat into there, and then just start touching the other side of the wire. Usually goes pretty quick. Boom. And once again, this thing will get very hot as you're holding on to the power distribution board. So it's usually a good idea to grab something to hold it, not your fingers. I usually use my tweezers to do that. Down, grab a pair of tweezers, or whatever you want to hold it with, until everything's melted. Oh, this is nice and awkward. So you don't want to make sure that it doesn't lift off like it just did there. So when you remove the pressure of the iron, sometimes it likes to lift off. So let's hold it a different place. There we go, that's better. So there you go, nice strong joint on there, fully flowed all the way around. You want to make sure you get a good joint for this one, because this is your LiPo connector where all your power will be running through. And so what I do after that is I kind of just measure out the second one so that it wraps under, trim it, and then expose the wire. Tin that one. What you can do is you can take the standoff off if it's too tight. I usually just grab it from a different angle, but if it's too tight, just take it off and you can do it then. Apply the heat to make sure it all melts. There it goes. Hold for a couple extra seconds, let go. And there you go. You got your power connector connected. To double check, so negative, negative, positive, positive. Good. So with the batteries, when you grab them, there's no way you can plug them in backwards because of the keyed connector. So you never have to worry about it again. Alright, so now that that's done, we will go around to all the motor wires and just tin them. So these guys are pretty easy. You just, because they're so small, let's clean that off quickly. They're so small. Put it down there to tin it again. And you just hold it for a second, and you just touch it. And it really does not need much to go. Alright, there you go. All the motor wires are tinned. Ready to go. So next step. ESCs. Let's get this stuff out of the way. ESCs. So these guys, if you buy them from us, will have no motor wires attached, and the heat shrink will come unshrunk. So this saves a lot of time on your behalf, because you don't have to remove these motor wires and remove the heat shrink and then find new heat shrink and replace it. All comes ready to go. So just pull the heat shrink back a little bit so that as we're tinning the motor connections, we don't get too much heat to the actual heat shrink itself. You can remove the heat shrink completely, but I like to just kind of protect the ESC with a heat shrink on it. Pull them all back like that. Clean off our tip. Solder. But every time you clean it, you should just touch a bit more solder so that it's got a bit of solder on it. And then just touch each ESC pad. Okay, so now that these are nicely tinned, they're all ready to go with the motors themselves. I'll slide them over. And just grab a single one. And we'll start with the back right motor. So with the BL heli that comes flashed on these particular ESCs, you'll have to make sure that these motor wires go in the right directions for them to spin the correct direction. So for these ESCs, the BL heli 13.2 with Armattan motors, for the reverse threaded motors, they all are straight through. So for this motor and this motor, the wires go straight through to the ESCs, no twists. However, for these two, you'll have to cross any two of the wires when soldering them. So we'll start with this guy here. And this is where the tweezers come in real handy for soldering these things together. So I just cleaned my tip, so I just put a bit more solder on there. And as mentioned, these will be going straight through. So just line it up there, hold it on, let go, boom, good. So again, this shows the importance of tinning both surfaces before putting them together. So if you tried to say if you had solder just on the ESC and not on the wires, and you try to push that wire in, and it wouldn't go in properly. You get a cold joint there. So there you go. That's all soldered up, straight through. Again, straight through for the back right and front left. And again, this is just for this BL Heli 13.2. If you're using a newer BL Heli or maybe Simon K, that order might change. And the nice thing that you can do here is I don't actually shrink this heat shrink down until after I've tested the motor directions. So I'll slide the heat shrink down over the ESC itself, but I won't actually shrink it. The nice thing is the heat shrink on here is quite tight, so it isn't too bulky, so you can just leave it like that. Next step is to put all the motor wires, the power distribution wires onto the power distribution board. So the first thing we'll do there is I will go around and prime all the spots for the ESC wires. Like so. There you go, one completed. I need to just stick this out of the way for now. I'll go to the other motor, grab another ESC. And once again, so now these ones are going to be reversed. So any two you can cross over, so you can either pull this one over here, put it on the far pad and put this one in the middle pad, or you can do the opposite, push this one over here and push that one over there. So I usually do this one, these two switched. So we'll start with this one. So there you go. Reverse two wires, and these two are standard. So I'll come back when we've done the other two. Alright, there we have it. We have all 4 ESCs attached. Once again, the heat shrink on them is still loose, both on the ESC itself as well as the covering heat shrink. So when you're doing these pads, make sure the entire pad itself is melted. So if you're just touching your iron to it and holding it there, and then you let it go, you might just tack it on, but you need the entire pad to melt properly for the entire thing to flow. So just make sure when you're melting these guys on that you see the entire pad liquefy. So I think the next step we'll do here now is to put the 5-volt regulator in place. So again, there is the way that if you take the original headers, where are they? So they usually come with a 5-pin header, so you'll have to break off 2. You'll have 3 pins. And what you can do is you can solder this guy into here. Well, if you're going to do this, you probably should do it beforehand because you'd have to solder from the bottom side. And then you push this guy down onto here, solder them in place, and then trim these pins down. However, this does lift the regulator up a bit more, and I like to keep it low profile. So what I do is actually get rid of that, and I'll solder this directly onto here. And how I do that is I tin the 3 pads here and the 3 pads there, and then I just kind of melt them all together. So we'll start with the Pololu regulator, clean the tip, and then just touch solder into the top sides of these pins. So flip it over to those same 3 pins, shaking like hell, apparently. So there you go. So all these 3 are primed now. So you should see little bubbles on the bottom side. The PG and the SHDN or shutdown pin don't have to be connected to anything. They can be floating. So now we've got those 3 primed. We'll just quickly put the 3 on the board, prime them as well. So you got 3 little bubbles there for the Pololu. And how I do it, and you do have to be a bit more careful when you're doing it this way. You kind of just line up the bubbles underneath with the things on top. Touch it so it melts the bubble, and then tip the iron down and stick it down into there. Just for a second, just so it flows down into the bottom piece. So if you do the first one, it should not move. Don't try to push it too much because you might rip the joint, but you probably can't see it through there. Maybe, maybe not, but you can see how it's flowed down from the Pololu down into the power distribution board. So do the same thing for the other 2. Just touch it until it melts. Push it down, hold it for a second, and then pull it out. Same for this one. So there you go, you can see all 3 of those have bridged between the Pololu on the top and the power distribution board on the bottom. This makes for a nice low profile build, as well as a very solid connection between the 2. And just to check this, I usually like to get my multimeter out and just check that connection, make sure nothing is shorted or anything like that. As well as just in general, you should check connections as you go. So I just got my cheap Mastercraft thing, put it in continuity mode. Grab your 2 prongs. And basically what happens, if you've never used one of these before, this shows the resistance that you have between the tips here. And so right now it's infinite resistance because there's only air connecting them, and air is not very conductive. But you touch them together and it'll go down to close to 0. So it won't go exactly to 0, but this basically means there's a short between the 2, and that's because we're touching. Ooh, sorry. So if we touch, for example, the ground tab here and the ground tab over here, you can see that drops down to about 0.04 ohms, or 0.03, which is good. What you shouldn't get now, so we have ground here, and if I touch this to the positive, there you go. So there's no connection between ground and positive, which you definitely do not want, otherwise you would get some flames. And then the last one to check is between ground and the 5-volt rail. So I touch those 2. There we don't get anything, and then 5 volt and positive. I don't get anything there. So When we connect the battery, we shouldn't get any flames. Alright, so that's all hooked up. A couple small things we're going to do right now. We'll hook up the JST, so this goes to the flight controller, to the battery monitor pins on the far side here. So you can see battery plus and minus. So we just got to solder that to a spare spot here. So I usually just kind of mimic where it'll sit. I usually put them like right about there. Boom. It's also obviously better to leave too much than too little. Otherwise it'll make it difficult to get the board on and off. Probably can't see in the video there, but you can see the whole pad melts. That's what you want to see. Alright, so that's our power connection. So it'll sit right about there. So the nice thing is with having the low profile Palulu under here, the way I connect the headers on here allows us to basically sandwich everything in between, and you won't be able to see anything on the outside. So it makes for a very nice, clean, and also very protected build, because you have no pins that you can really hit. It may crash or something like that. What else do we need to do? Oh, right. So what I like to do, because basically you need to have a connection between the 5-volt regulator and this flight controller, because there's no 5 volts coming through these guys, you need another connection for that. So this power connection is only for monitoring the LiPo voltage. So if you have a buzzer connected, or if you have an OSD connected, such as the minimum OSD, you can actually read out that battery voltage because this is connected. However, this doesn't give you any power to this board, so you actually need to give it 5 volts from somewhere. So you already have the ground connected, so you only need the single line for 5 volts. So what I like to do for that is you take the supplied breakout cable for this unit, and obviously because you should be building this without PWM, so you shouldn't have to use this cable, because this takes up a huge amount of room. As you can see, if you say you have this installed here, you have your header there, you have this thing sticking out, basically it works, you can do it, but you're creating a lot of extra weight, a lot of extra space. And I highly recommend that you use a PPM or a satellite receiver that only requires a single signal wire between the receiver and the flight controller. Anyway, so we don't really need this guy, but we can sacrifice him for putting in a 5-volt connection. So what I do is I just grab a random one, snip him wherever, and get rid of this guy here. So what we're going to do is basically solder this wire directly to the 5-volt out. So you can put it down here, or you can put it up here. I like to put it just right on the Palulu regulator, so there's less room for error. So we'll just take the end off of that, like so, and then tin it. And we'll basically take this and connect it directly to the 5-volt output on the far side. Like so. Basically now this is our 5-volt going to the flight controller. So what you can do is if you solder all 6 pin headers on here, you just got to change this to the middle slot. Or what I like to do is I will pop the entire thing out, and then slide this connector. So this is 5 volts, and so the center pin on these connectors is supposedly 5 volts if it had a 5-volt BEC, but it doesn't. But now this is 5 volts, so we just slide it into here. Boom. And now we have a connector that has 5 volts going to the flight controller, as well as grounds here as well. So I just kind of curl this up and stick to the side. So there we go. So that's basically all of the work done on the base power distribution and regulators. And so the next thing to look at will be the flight controller and the receiver. We'll get this guy out of the way for a second while we do the flight controller side of things. So for these builds, I highly recommend doing it the following way, just because the area is very tight on here. You want to keep everything in towards the center. Let's just start by, so this, you can leave the case on this guy, but you can reduce the weight by removing the case, as well as it makes it a bit more lower profile. And to do that, you can just pop the screw out of here. Is this the right screw? There it is. This is for the lemon receivers. Pop the screw out, toss it. Don't need it, and then you just have to be a bit careful here. We basically just have to pry this thing apart. So you don't want to scratch the PCB underneath any at all if you don't have to. So just be careful if you're using a knife. I usually just kind of pop the corner out, and then you can usually pry the entire thing apart. So obviously this is not required, but it does make it a bit more low profile. You just toss the case away. So for this, the pins that stick out the bottom actually stick out quite far, so I just take my side cutters and just shorten these right down. Nice and flat. Well, not super flat, but they poke out less. And then we have our flight controller. So because this is a quad, we're only using 4 of the motor outputs. So the last 2 are not required. So you can leave all 6 and just solder the whole thing in directly, but I like to remove the 2 extra ones, just so there's more room between the power distribution board and this guy, as well as reduces the weight ever so slightly. So I just take these guys and break it off. You have to be a bit careful with this so you don't break the whole header apart, but there you go. So now I got 4 left. That's all we need. And so to solder these in, the best way that I find to do it, rather than trying to hold it with tape or anything like that, is I kind of just squeeze the header together a little bit. Not too much, just to bend the pins in a tiny bit so they're not perfectly straight anymore. And then once that happens, then you can just slide them in here. And then the pressure of them being, oh, see, they're not, see how that's too loose? So we gotta squeeze them in a bit more. And then it'll kind of pinch on itself so that it won't want to come out. There we go. So that's better. So we're soldering it like this, it's not going to go anywhere. Once again, clean your tip. And this guy just requires a little touch. Not much. Hold it there for a second after you touch it. And then usually, right after that, I usually just check and make sure everything looks okay. Nothing's moved, it's all straight. And we keep going. So one thing to be careful about with this is that you do get enough solder going down into the pins. So you should see a nice kind of like bubble almost around the pin itself. There you go. There's all those pins done. Gotta watch out, it'll be warm. I'm using these metal grippers. I don't recommend it. I'm really careful. I keep them around the holes for where the bolts go through, because there's not usually any important traces going around there. But I recommend something that's not metal, because this can scratch through the solder mask and ruin any traces that you might have under there. So just be careful with that if you do have metal ones. Then we just do the exact same thing. So this is the header for the battery pin, the buzzer, and the FR Sky telemetry. I usually solder the whole thing in because sometimes people want to use telemetry or buzzer. I usually only use the VBAT port for battery monitoring. That's the far outside one. Same idea though, you just kind of squish the headers together a little bit so they're a little bit bent. And you slide it into place, and it usually will hold itself in there. There we have it. So we have our motor headers soldered over here, and we have our battery and other auxiliary pins on the other side. And so I solder them to the bottom, facing inwards. This means it keeps everything nice and tight underneath when we actually connect everything together. You don't have any pins sticking out the side, so if you crash or anything, you can't strike any pins, bend anything, break any boards. It's all protected. It also looks a lot nicer and cleaner this way. So the next thing is we got to attach the receiver to this little guy. So with the Spectrum or any DSMX satellite receiver, so they usually have the 3-pin connectors going to a standard RX, but we don't have a standard RX, so we're going to be using this. It's a standard RX receiver. So I usually just do it this way. I plug this in. I usually double side tape onto the middle of the flight controller here, like this. So then you have 3 main connections that you need for this. So in this case, the red wire here is 3 volts. And so there's a 3 volt tab here, it's 3 volts. Black is obviously ground, so I put ground to there. And then the yellow is the signal wire. And for these, the signal wire goes to pin 4 on the bottom side here on the receiver side of the tab. So we basically need 3 connections. We've got a prime, we've got the 3 volt, the ground, and the pin 4 there. Yes, now that those are primed, what we'll need to do is figure out the lengths of these wires. So I usually will just get an idea of how far these need to be, about so. Trim off the most of the connector, or the extra wire, don't need all that. Toss it. And then we can go from there. So the most important one to get first, that I find at least, is to get this power wire first. So get it to the right length of the receiver sitting where you want it. I just use some 3M VHB or very high bond double-sided tape. This stuff is great. It's also very good for isolating gel if you need it, because it's kind of like a thick layer of silicone. And it sticks very well. So I usually just use a small square, like so. Of course, everything gets stuck to it, so there's hair everywhere, dust and stuff. So you have to try to keep as much of that off as you can so that it sticks properly. Then I just place this over the bottom. I usually try to cover those exposed pins there so that it doesn't short anything on the flight controller. Alright, hardest part of the build right there, getting that damn stuff off. Anyways, so we'll just make sure that this lines up properly. So the most important one is getting the power one first, so just line that up like so, and then just stick this down on like that. You don't have to push it too hard, it just has to sit. Usually I just stick it on there like that, and we're good to go. Just double check nothing's shorting. If you push it down too hard, sometimes things can touch. And depending on how thick the double-sided tape you use, you'll have to check that as well. But the stuff I use is pretty thick, so it'll work fine. And there you go. You now have a flight controller and a receiver all built into one. So we've got everything now assembled. One thing I do like to do is tidy up the signal wires a bit more. But before I do that, let's actually just power it on and make sure everything beeps properly. So basically you should go over, recheck everything, make sure all the connections are right. And if you can, use a multimeter to check if there's any shorts between any of the grounds, the positives and the 5-volt lines. If that all sounds good, grab yourself a 3S LiPo, doesn't have to be any particular size, and plug her in. There you go, so it sounded like everything beeped, we don't get any fire. Good to go. Obviously it won't do the full set of beeps because it is not receiving a signal through the signal line. You'll just hear the single beep for now. But that means we're all good to go. So we can start putting, actually, you know what? So in terms of tidying up, I just like to have the servo lines kind of zip tied in. Alright, so that'll make it look a little bit cleaner once we have it all bundled up inside. So for the Clean Flight quad configuration, the motor numbers are 1, 1, 2, 3, and 4. And that corresponds to, if we're looking at that, that's the front. 1, 2, 3, and 4. So let's connect those guys up. So with this underside installation of the headers, if you do it this way, keep in mind that the signal wire is on closest to the board, and then ground is on the far side up here. So this is also our special wire here, so double check that this one is correct. So again, signal, the white wire goes towards closest to the board, and the ground is on the top side. Now the board has 5 volts, and we will also connect the signal line, or sorry, the voltage monitoring line. So for this one, again, same as before, the red line will go towards the closest to the board, and the ground will be on the bottom side. Like so. So what I usually like to do for tucking these guys in, and I think about it, actually, sorry, I'll take that out. I usually just give this guy a quick twist. So we wrap all the lines together. You grab your short nylon bolts. Make sure you use nylon on this. You don't want to shorten anything out. It's a Phillips or flathead, so I just got my Phillips. Don't tighten it down all the way yet. Let's make sure all the wires are out of the way. So you just check that none of the wires got between the board and the standoff, so they don't get squished. So there you go. As you can see, with the pins having been inside like that, it's all nicely contained. There's nothing poking out the sides and nowhere that pins could get hit. It just looks a lot cleaner when you have a build like this with the pins facing internally. So that's about all you gotta do for now. Next steps will be configuring it on the computer and checking a couple things, and then actually, you know what, let's put the top plate on right now and do it. Usually I do this, I wait until later, just in case I do need to pull the mullet off, but it's not that much work. So these are using the M3 short metal bolts going to the top. Don't tighten the first one all the way down until you've got the second one in. There we go. So, oh, right, last thing. LiPo strap. Gotta have the LiPo strap. I usually slide it on top of the carbon fiber layer, underneath the power distribution board, the right way up. There you go, that's basically 99% of the hardware installation done for a line of sight bird. Obviously if you're going to add FPV gear, you would do so on the front and the back, as well as if you want to add the accessory plates for the front and the back, either for covering stuff or for double mounting. This kind of would go out into the front and the back sections here as well. So only a hardware thing to do after this is to shrink this heat shrink down, but I only do this after I've checked all the motor directions in Clean Flight when I boot it all up. So I think the next part of the video will be about setting this all up.